GATE 2019 Civil Engineering Set 1 Question 47. A parabolic vertical curve is being designed to join a road of grade plus 5% with a road of grade minus 3%. The length of the vertical curve is 400 meters measured along the horizontal. The vertical point of curvature VPC is located on the road of grade plus 5%. The difference in height between VPC and the vertical point of intersection VPI in meters need to be found, rounded off to the nearest integer. The relevant NPTEL reference has been cited. One needs to know about the vertical curves in the geometric design section of transportation engineering to solve this problem. So vertical curves are essentially meant to smoothen the transition between two gradients on a road. So if we have a gradient that is plus n1 and we have another gradient that is minus n2, so if we build a road along the plus n1 gradient and the minus n2 gradient, the vehicle will go like this and it will suddenly descend like this. So this will cause a sudden discomfort to the passengers. So in order to smoothen the transition, we provide a curve which is parabolic in shape in some manner like this. So this is called a vertical curve. So here the curve will start from one point that will be called the vertical point of curvature, and the another point will called vertical point of tangency. So this will be the length of the curve that is called as L, which is measured along the horizontal. This will be the vertical point of intersection where the two tangent points intersect. In order to provide design symmetry and ease in construction and design of the vertical curve, we ensure that the vertical point of intersection generally lies at half of the horizontal length from both sides. This essentially ensures that the tangent length from the VPC is equal to the tangent length from the VPT. So VPI lies above the center of the vertical curve. In this case, we have been given the first gradient as 5% and the second gradient as minus 3%. The length of the curve is given as 400 meters. So what we need to find is, this will be a steeper gradient, that is the 5% gradient, and another gradient will be little flatter, so that will be the 3% gradient. So this is our 5% value and this is our 3% value. So the VPI will lie somewhere here. So as we saw in the previous slide, we ensure that we provide half the distance on both sides of the VPI for ease in design and construction. This will be our VPC, this will be the VPT. We need to find the difference of height between the VPC and the VPI. Let us call this height as capital H. So if we consider this triangle, let us call it A, B and C. So if we take this triangle C, A and B, so the slope of this line is n1, the height is h, and this length is L by 2. So n1 will be h divided by L by 2. So n1 is 0.05. We will convert the percentage to decimals. L is 400 meters, so L by 2 will be 200. H will be 200 times 0.05. This would give the value to be around 10 meters. The question instructs us to round it off to the nearest integer. So here we obtained the value as an integer itself, so we will leave it as it is. So a parabolic vertical curve was being designed to join a road grade of plus 5% and minus 3%. The difference in height between the vertical point of curvature and vertical point of intersection was found out as 10 meters. The relevant NPTEL reference has been cited.